You got 30 seconds to finish it up. You're making that harder than it has to be, Lexi. So I need y'all to pay attention because some of us are making this one significantly harder than it has to be for sure. The second one, we should be able to finish in probably about 30 seconds. Which I know y'all are going to look at me like I'm crazy. But, so looking at this question here, I'm asking you to rewrite the exponential equation 5 to the x equals 87 as a logarithm and evaluate. And most of us got log base 5 of 87. And Gracie had an interesting statement that there is no log, or 5 to a power does not equal 87. Is that true?
Not a whole number.
Okay, that's important to remember. Not a whole number, not an integer. 5 to the second is 25. 5 to the third, anyone know what that is? 125. So this needs to be a decimal somewhere between 2 and 3. Which is why we need logarithms, because I don't know the answer to that off the top of my head. And I guess you could have written it this way. That would have made sense as well. But notice, your calculator can do this. Just type in log base 5 of 87. Right? Remember using inverses, because Lexi, at this point you were doing this, weren't you? Using an inverse. But notice that's literally just going to get you back to this. No, we want to isolate the variable x, we want to solve for x, and so all I have to do is type in log base 5 of 87. And so you should have gotten 2.77, apparently going pretty far out is 482, is equal to x. Which means what? What does x equaling that number mean? It's a what? That's an exponent, right? What we're saying is 5 to the 2.77482 is approximately 87. Check that. Type in 5 raised to the 2.77482. Can you hit it? Yeah.
Okay, so 10 to the...
Nope. Why'd you put a 10?
Okay.
It's base 5.
No, it's
87 point what?
I got 86.9.
86.99. So remember, we had to round this decimal. This decimal is probably what? Irrational, right? So is that the full decimal? No. Right, so it's irrational, so there is no exact value. And notice that's why I put the squigglies here, the approximately equal to symbol. It's about 87. It's a little off. If we had a bigger decimal, it would probably be more accurate. So determine the product of 2 times x minus 1 times x plus 2. We're still struggling with this a little bit for some of us, but I need you to pay attention to this because this is where I'm seeing some students make a mistake. First off, what is this student referring to? That's the what? Roots. I'm not asking for roots here. I'm asking you to find the product, meaning you what? Multiply, right? The product is multiplication. Next, do not forget, because I saw some students making this mistake on the understanding check, it is easiest to multiply what first? X minus 1 times x plus 2. Does anyone remember what these are called? Binomials. Remember, these are special types of polynomials. Poly meaning many numbers, binomials meaning 2, right? Bi is 2 numbers. So x minus 1 times x plus 2, it is easiest to multiply those binomials first. Now, could you distribute that 2? Yes. Will it make your life harder? Yes. If you multiply the 2 first, you only multiply the 2 by either the x minus 1 or the x plus 2, not both of them. It's only by one of them. So you could do 2x minus 2 times x plus 2. Notice I distributed it into the x minus 1. You could do x minus 1 times 2x plus 4. Notice I distributed it to the x plus 2. That is not what I would recommend. You can do it, but that's where a lot of students make mistakes. You can do distribution, or my favorite at this point, because it's helping a lot of you, not personally how I do it, but I think a lot of y'all who are doing this are getting it correct, is using this area model. X plus 2 times x minus 1. What is x times x? X squared. Remember, we are multiplying, right? X times 2. X times negative 1. Negative x and negative 1 times 2. Remember, within the area model, you can also see your like terms. What are the like terms? 2x and negative x. So I'm going to add my like terms. X squared, that's all there is. 2x minus x would be plus 1x. And then minus 2. You just have to remember afterwards we're multiplying by 2. So distribute there. 2x squared plus 2x minus 4. So those of us who did this, a lot of us got it right here. But we need to be careful about that. Don't forget, if it had been like an x plus 3 here, right? When you got down to the step, obviously that's not what's here, so pay attention to that. But once you got down to this step, am I going to add x plus 3?
No.
No.
You're gonna multiply it.
Thank you. You got to be careful and remember that that's multiplication, so I'm not going to add the x plus 3. It would then be times x plus 3. So I'd have to distribute again or use the area model to help me organize that distribution. Pay attention to those details. Alright, getting back to where we stopped yesterday, okay, we are focusing on Module 3, Topic 3, Lesson 1. Remember, we're still working with logarithms. We skipped a little bit of the logarithmic functions, specifically the transformations. Remember, I took transformations off your graphic organizer. I want you to hold on to your graphic organizer, but you have got to remind me if I forget by the end of class to collect it, because we're going to get to a couple of terms that are on the graphic organizer that I want you to see where they are. And that's within, that should not say transformations, that should say, for the second part, it's properties of exponential and logarithmic expressions. I don't know why I wrote that. Ignore that detail. So we're on this lesson 1, all the pieces of the puzzle on M3-171. Right? So we're looking at M3-171 is where we started. We got a little bit into this. Does that sound correct?
Yes.
Say again.
Like this.
You like this? So remember, we're trying to convert exponential equations into logarithmic equations, converting logarithmic equations into exponential equations. And then we're going to get today into estimating the values of logarithms on a number line. We need to get comfortable with what a logarithm is so that we don't forget it. Because a lot of students who do logarithms are just used to plugging stuff into a calculator and have no concept of what a logarithm is. But logarithms are really useful, and understanding what the value of a logarithm is going to help you in the next lesson. Alright? So we did this yesterday, y'all blew through this where we took these 3 numbers, right, and we made logarithmic equations out of them. For example, what was the equation we wrote here for b on, what is this, 173? Log base 6. And so this was the one that gave you all the most trouble, wasn't it? But you got to remember what a logarithm is. When we evaluate a logarithm, we're getting an exponent, right? And that's what it should have been a tip here, because if we have a negative exponent, remember that's not repeated multiplication, that's repeated division. And so be careful, and this is why I always tell y'all to work on your language with it, right? Grace even started to say 1 over 216, and then you tried to say 1/216, which is really awkward.
Well, you told us not to say 1 over 2.
Right, so what would have been the easier thing to say there? And I'm commending you on trying to fix that language, but what would have been easier? 1, what does that mean? Divided by 216. Because remember, what is a negative exponent? It is repeated division, right? And so those are the things that we want to notice, is that we have a negative exponent, so it's repeated division there. So we talked through this yesterday. Remember, I told you, am I approaching it the way that they're doing here, where they're rewriting, was it log base 4 of 64 equals x, and then they're rewriting it as 4 to the x equals 64, and then they're going through all of this to rewrite it so x equals 3. Is that what I'm doing?
No.
No. I already have x equals, so I'm going to just plug that into the calculator. Or think through, what is the exponent? I'm not going to make it more difficult than that. Here, they got b cubed is equal to 64, right? We use our inverse, and the inverse of a logarithm is an exponential, right? So b raised to this log, those are inverses so they cancel, and that's how I get 64 equals b raised to the third. Instead of making my life difficult, I'm just going to use another inverse. What inverse should I use here?
Cube root.
Cube root, right? It's cubed. So the inverse of that would be a cube root, right? So I'm just using all of that information to my advantage, using my calculators to help solve it. I just have to recognize what is the inverse. And that, I believe, is where we ended yesterday, and this is where we're going to pick up. Write 3 logarithmic expressions that are equivalent to each given expression. For instance, log base 5 of 625, anybody have an idea what would be equivalent to that? Okay, so it equals 4. You can type that into the calculator and get that it's equal to 4, because 5 to the 4th is equal to 625.
So you have to make a logarithm equivalent to that one
Mhm.
that we're doing? Okay, so you could use the one from yesterday that also equaled 4, which was log 4 raised to the 256.
So log base 4, and so be careful, we did talk about this yesterday. Is this log base 4 raised to the 256?
Yeah.
No.
Log
Base.
base 4 of 256. Notice it's not an exponent, it's more that the 4 is a subscript. Because where's the exponent?
It's on the other side.
On the other side. Remember, what the logarithm equals is an exponent. So is that equivalent? I mean, are they both equal to 4?
Yes.
So are they equivalent? Yes.
Yay!
Even though they're different bases, they're equal to 4. Does that make sense? Okay. So we need to think through these things. Now, I want to point this out, because I don't want you to just use a calculator. That is not the point of today. To type in a logarithm and get it that way, you need to think through these things to build better understanding of what's happening. When I look right here, log base 7 of 1/7, what kind of exponent should I be thinking about? A negative? Any ideas? Negative what? Negative 1? Does 7 to the negative 1 equal 1/7? Or 1 divided by 1/7? Yeah? Uh-huh. So we want to recognize, we need to think through the fact that we're trying to get exponents here, and so that's an important part of this. I'm going to do, and so I'm going to leave it there so that y'all can think through creating a few more equivalent expressions, but I do want to talk about C really quickly. Any ideas on C? What do you mean? So if I do 64 to the maybe negative 1. 1 divided by 64. Notice, do I have repeated division here? No. Huh. So remember, this is actually something we haven't dealt heavily with this year, but we talked about for a decent bit yesterday. Does anyone remember an operation that I can do to 64 to get it to 8? Come on, you're about to say it. Okay, the square root of 64 equal 8. Yes? And so we need to remember, we talked through yesterday, how to write that as an exponent. 64. So don't forget, well, it is the square root, so remember, what is the number that's understood to be here that we don't write? 2. What's the understood exponent on the 64? So how would I write that as an exponent?
1/2.
1/2. Right. Remember, the actual exponent is the numerator of the rational exponent, and then the root is, or it's called the index of the root, is my denominator. And so, when I look at this, we want to recognize that I'm taking a square root. I'm not dividing, so it's not a negative exponent, but it is a root that I need to take. Okay? And so we're going to use this to help us build our understanding of different roots as well. But I want you to play around with this. Let's take 5 minutes, develop as many logarithms as you can during that 5 minutes, and we'll have a discussion afterwards. Let's get to work.
This one, it says I have to solve it in the calculator, so can you not do the negative? How do we know that? With the opposite
For C.
So are we supposed to try how to do it at like make a logarithm?
So for B, it would just be that number,
I would check that again. What's 2 to the negative 1?
like, you see how it's 7?
Yeah.
So it'd just be that number, and then
Positive
1 over the other, whatever the second
We'll
number.
just work on that language a little bit.
Right?
Positive 1.
So if it was like log base 6,
You're saying positive 1 over 2. What's the issue I have?
Is it positive?
It's not the issue I have. Yeah, say it.
So maybe.
Okay. Why do I want you to focus on the fact that it's 1? So 2 to the negative 1 would be 1 divided by 2. Why am I emphasizing that detail?
Oh, so we know it's negative. But it, would it be?
Remember, what is a negative exponent? Repeated. See, that's the issue. Division. A positive exponent is repeated multiplication. So a negative exponent is repeated division. Focusing on that will help you understand here. But that means it's not a negative.
oh, I just think it's.
Right? And it's not a negative.
Whatever
Now
number you
remember,
put as
hey,
the
really
base.
quickly, y'all, please note you're supposed to do 3 logarithmic expressions for each of A, B, C, and D. Just like Gracie's idea of log base 4 of 256 was equivalent to log base 4 or base 5 of 625, you need 3 different logarithmic expressions for A, B, C, and D. Okay? So let's try to develop as many of those as possible.
So like you would just write.
So focus on, I will say this, focus on A, B, and C before you do
And
D.
then whatever number is, you put it over.
Whatever exponent it
So we
Yeah.
can't have a negative
is. You
in
do.
there.
So like the exponent is gonna be -1. So I just put a random, like just put log, and then I just put a random number,
Well, let's just do equivalent ones to the other.
and then so just put like.
Remember, we're not just typing in log into the calculator.
And then you
put
put
the answer.
1 over 8.
Because you already have log base 7
Base
and 1 7. We already did that on the board together.
You do these two.
And then I think you can
Look again.
just do that for any number.
So for C.
Remember we talked to?
No.
But okay, it's not, if it's not possible, it's not possible. But I asked y'all to focus on A, B, and C. You're getting distracted. You're supposed to do 3 logarithmic expressions for each of A, B, and C.
What's in the middle for A?
But then why'd you look at D?
Okay.
So how'd you find
You're making this too complicated. Have you done 3 logarithmic expressions for A, B, and C?
Eight, yeah, because
So focus there.
log
And so,
8.
Nathan, you came up with log base 2 of 16.
Equals -1.
And that equals 4. But you also just type that into the calculator. I want you to be thinking through these things instead of just typing into the calculator. Guys, think through these, don't just type them into the calculator to build your understanding of logarithms. Because I want you to think through, and this is probably what you did think of, and you're just checking it, right? But 2 to what power
Now
gives you
this one.
16? Well, 2 to the 4. So like, write it out though. Notice you know that you want what exponent? 4. So that's 2 times 2 times 2 times 2. So think through that detail.
5 to the wall.
You already have log base 5 of 625 equals 4, because
So
5 times 5 times 5
Yeah,
times
we're
5
trying to
is
equal
equal to what?
And then 4 to the.
And then we have
How
log
much is
base
4
4
to the
of 264 is equal to 4, because what's 4 times 4 times 4 times 4?
4 raised to the 4th is 256.
Or 256, my bad.
Oh wait,
You're right.
no.
So let's find one more that we know we can do, that's gonna give us an exponent of 4. But try thinking through it, so just type it into a calculator.
25.
Yeah. And then 4 to the 4 is 2.
Just cause you have the right idea, but look again at, B, the last one again.
2 times 3 is 9. 9 times 3 is 27.
Also, you already have long base.
Someone's one of the guys,
And then 27.
it's like
Was
standing
that-
there next to the paper. It wasn't the good
Oh, okay.
one, it was the other one.
Yeah, it was so close, I
Yeah, and I was like,
I mean, you know it's a 4, you can go. Okay.
but that's like putting me next to
I mean,
like.
Have
it's
you
a
done your
pattern,
3
now
for
it's
8?
like 4, so I'm
I bet she really was she could try to do it, but she told me she couldn't get through.
You don't need to plug in numbers, think through this. You have to plug in. Right, but think, it's not that you can't, but I want you to focus on thinking through it first. Why did it, how do we know log base 4 is equal to 6? It's equivalent.
4 times 6.
Wait, is it 3 times 3?
Is that the same exponent? Can you think of any bases that you could just raise the
Oh, wait.
exponent to figure out the logarithm?
She had to put another one.
3 to the,
4 times 6 is 8. 8 times 2 is 16.
and so if you want to do that in the calculator, sure, but what's 3 times 3?
You're always getting to compare something.
Or you can do it, yeah, you can do it that way as well, but notice 9 times 9 would be,
I don't know.
so it'd be log
I'm not
base
even
3
doing
of
log of 1.
equals.
Yeah.
This is what I'm trying to get y'all to get comfortable with, is that if we know what a logarithm is equal to based on the fact of the exponent, right? So use that to help you move through these ideas.
I don't know how to do so.
Okay, log
Yeah.
it equals 0.5. So we have to find the other ones that equal 4. Oh, it's half. What was the one you said? Like 64 divided by 8.
So this log
Well, remember,
16
so, because remember, what did you say earlier, Kameryn, that it's the what? Square root. Is the square root of 16 8? Right, you were saying earlier that 64 to the 1/2, or that's what we discussed, is the same thing as the square root of 64. That's why it's 8. So what you're trying to think about is 16 to the 1/2, the square root of 16 is what?
We gotta do the
Oh, so we have to get.
log. Wait, I thought you said I had to equal
Mm-hmm.
Okay.
So log base 16 of 4 is equal to what?
number.
1/2. Oh, so it is the same.
Because remember, that exponent of 1/2 is the same as what? A square root. Okay?
So log 6, so we can do log 25, 5,
Yeah.
and then log 9, 3.
What was the last one you said?
9, 3.
I can't, why am I struggling with spelling log? I always put LO6.
Like this is 2 times 2 times. You know where like this? Every, you trying to say you don't know how to write on this? What's 2?
You said we don't have to do
If you finish the others, go on to it, but I wanted you to focus on A, B, and C first.
That's not the right answer. Oh.
That is the right
That's
answer.
it.
Okay.
Because isn't it negative?
Think through it first instead of just typing into the calculator.
I found something that if you round it down, actually no, that would be 2. Would be.
Yeah, it'd be negative
1
1.
divided
We need negative 2.
to the 1. That's the same thing as.
But that'd be negative 4.
Equals 4.
Yeah, sure. I mean,
I think it is.
to the negative 1.
Yeah.
Negative 2, right?
Yeah. So it's just 1. So,
So it's negative 1.
right.
There we go.
So
So it's the same thing as the one up there?
Okay.
We would just write the same number.
Let's talk through some of these.
So it'd be like log.
We should at least have one or two for A, B, and C. Grayson, give me one that your group came up with for A.
Log 581 equals 4.
Log base 5 of 81 is equal to 4? What do y'all think?
I was 3.
I think you might have misread that number. 3? Okay, is that true? How do we know? They have the same exponent, but, I mean, how do we know that that is a correct statement? How do we know that the exponent is 4? Okay, Shannon, focus up here. If you want to have a,
I'm
huh?
trying to see if I got this right.
Which one? So, how do we know that it's log base 3 of 81 is equal to 4? How do we know that?
Because 3 raised to the 4th is 81.
Okay, let's go more fundamental than that, because if you go more fundamental, this becomes much easier. When we say 3 to the 4th, we're saying that we're repeatedly multiplying by 3 4 times, right? Y'all are struggling to generate a few of these, but we know 4 times 4 times 4 times 4, because we have 4 of them based on the exponent is 256. Okay? LaShannon, were you looking at one for A, B, or C? Because we can look at it as a whole class if you have a question. That's why I need you to focus here, and we can ask questions of the whole class. That'll help everyone learn more. Was it about A? Okay, which one was it about? Huh? Okay. You got one, KJ?
I said log base 10 to 10,000 or up to 10,000.
Oh, 10,000, there we go.
Equal 4.
What do y'all think? That should be how many zeros? 10 times 10 times 10 times 10? 4. Does anyone know a simpler way I could have written that logarithm?
Oh, you could have just left out the 10.
Not write the 10. Remember, if you don't write the base, it's understood to be log base 10. It's called the common logarithm. There we go. Does anybody want to add one more up here? We feel comfortable with this. Or ask if one of theirs works.
Wait, so you won't get wrong if you do that, right?
I recommend doing common log and getting used to that, but. Alright, let's look at B. LaShannon, can you give us one for B? Why don't you do it? Okay, well then, how about you look up at the board and we can discuss as a whole class. That might help you instead of getting upset that I asked you to pay attention. And I know that you're upset because I called you out, but legitimately I need you paying attention to the whole class discussion. This will help you.
I'm trying to figure it out, but you at me, like,
What?
you on me, I'm trying to figure it out.
But LaShannon, when it's whole class time, that's the time to pay attention to the board and that will help you figure it out. I'm not coming at you because I'm angry with you or anything like that. I'm asking you to pay attention because I know it'll help. You're getting frustrated, which is preventing you from paying attention. I'm trying to help you. Kameryn, can you give us one for B?
I put log, I don't know how to say it.
Base?
Log base 8 of 1/8 equals negative.
So it's log base 8 of 1/8. Is that equivalent? A negative exponent is going to tell us to repeatedly divide. And remember, if it's a 1, it needs to be the same exact thing, right? Okay? Jelani, did you come up with one logarithm here for B? No? Did you talk about it with your group at all to help you figure it out?
Yeah, I'm trying to figure it out.
Can't figure out one? Okay, well, I want you to think about it. I'm going to get one or two more from other groups and see if you can come up with one from that. Let's see, can you give us one?
Log base 4 of 1/4, 1 of 4.
The first way you said is more mathematically accurate. 1/4, or we would want to say 1 divided by 4, right? Making sure we understand this repeated division, right? Remember, the whole idea is that that's my exponent. 4 raised to the negative 1 is going to tell me to divide by 4 one time. Yes?
Oh, I get it now.
Okay, so give me one.
So I got log base 5 raised to 1/5 equals -1.
Okay? Does anybody want to push back on that, maybe on the language, or we all good with how it was said? Language? So you're good with with the answer he has? Okay, so tell me about the language.
He said 5 raised to 1/5.
Okay? And we want to be careful about that. How are we supposed to say this?
Log base 5 of 1 divided by 5.
Okay. Remember, Jelani, when you say raised to, that's indicating what mathematical operation?
Division.
Raised to. When you say raised to, what operation is that?
Exponent.
An exponent. That is not an exponent. Remember, the exponent is what the logarithm is equal to. My exponent is -1. It's log base 5 of 1/5. Or of 1 divided by 5. Yes, LaShannon.
Can I do one?
Sure.
Log base 10, 1 divided 10.
What do y'all think? Good? LaShannon, is what I wrote the same thing as what you said?
Yeah,
Yes?
yeah, 'cause you don't have to write
Good. I want you to recognize that. Okay, so now we get into the slightly more difficult ones. Let's look at C. Log base 64 of 8 was 1/2. KJ, did y'all come up with a logarithm here?
No, I didn't get that far.
We didn't get that far? Lexi, you got one?
Found it on the other page.
Huh?
Found it on the other.
Found it on the other page? What'd you get on the other page?
Log base 16 of 4.
So, remember, this right here is an exponent. What do we mean when we raise it to the 1/2? What is that equivalent to? Remember that 16 to what exponent? 1. But what does the denominator of 2 indicate? The square root. Remember, the numerator is the actual power, the denominator is my root. So is the square root of 16 4? Yes. Is the square root of 64 8? Yes. So we got to pay attention to what those exponents mean to understand all of this. Does anybody have another logarithm we might want to throw into the mix? LaShannon.
Would log 4, 8 be 1, but it can be 1.5, I think we should still have one.
What do y'all think?
0.5.
So 0.5 would be 1/2. So not quite. And remember what we want, the exponent of 1/2 is the same as a what? Square root. What is the square root of 4? Does that make sense? Do you want to try one more to see if you could come up with another one, or think about it for a second while someone gives us another logarithm? Think about it for a second. Okay, does anybody have another logarithm?
Log base 25 of 5 equals 1/2.
Of 5. Okay, so how'd you come up with that one?
The square root of 25 is 5.
Square root of 25 is 5. Remember, raising it to the 1/2 is the same as square root. Nathan, what do you think about this logarithm? You agreed. I think you had that one down, right? Yeah? You just don't like to say them out loud? Okay. What about log base 36 of 18? Is that equivalent? Nope, think about it. Don't pick up that calculator, think about it.
For which one, C?
So is it equivalent to C?
I think not, but like,
You think not? Why not?
I think it's usually the base is, since it's 1/2 is the higher number, it's the like wall.
Wait,
It's
what
just
was
a
it?
pattern.
I
36
mean,
of
18 plus 18 is 36.
It's true.
So that's
So that'd be
square
8.
But all the other ones had like log 64 to the like smaller number.
But it needs to be a what? Because we're missing on something over here. What are we saying? It needs to be a root. Notice I took a half of 36, didn't I? What's the square root
Yeah, it has to be 0.
of 36? Ah. Notice, and LaShannon, you went immediately to the idea of 18 plus 18. But a logarithm is an exponent, correct? So I don't want to be adding I want to be thinking about multiplication to get those exponents, right? Or repeated multiplication by the same thing. So I needed log base 36 of 6. We all good on that idea? Okay. Let's look at D. No, yeah, D. Did anybody come up with a logarithm for D?
We put log 3, or log base 3, log negative 3, but we're just guessing.
Okay. How about you do this for me? Everybody, pick up a calculator. Type log base 3 of negative 3 into your calculator.
How you, yeah. I don't
It's
know how to
gonna
do
tell me
that.
it's undefined or something.
I keep telling you it's undefined.
Yeah.
That's because it's,
It's
imaginary.
It's an imaginary,
I'll be honest, I need to look into that. I don't know if that is an imaginary number. Remember, an imaginary number
Oh,
is a square root of a negative, right? So let's think about it. Remember, a logarithm is an exponent, okay? And so that is equivalent, what would be the exponential form of this logarithm?
3n equals.
3n equals,
Yeah, raised.
raised to? So you gotta tell me that. So let me ask you this, is there any number, any exponent I could put on that 3 and get a negative out?
Negative 1.
Negative 1? What is 3 to the negative 1?
1 over 3.
Oh, negative exponent is repeated
What, division?
division. Is there any exponent I could put on 3 to get a negative 3? No, Mr. Kimmy. Great, guys. Think about this. An exponential function. What is, and this is why it's important to make connections. An exponential equation has ties to an exponential function. If I were to graph y equals 3 raised to the x, that's the basic exponential equation, what would it look like? Not a squiggle. Think about polynomials, not exponentials.
We talked about this.
Uh-huh.
It would be, well, the 3 is with the x,
A growth thing.
so it would be going left and right?
It would go from left to right, it'd be an exponential growth. Hey, what kind of outputs do I never have? Remember, outputs are my y's, I never have a negative, do I? It doesn't matter what exponent I put, will I ever get a negative? No, definitely not. Okay, we good on that? Okay. I realized that I skipped a section here with equations, and I went and added it back in. It's actually the previous question, number 3. We're going to come back to this later so that we get more practice, but I'm trying to think if I want to do any of these right now. I don't. I'm just trying to think through. Yeah. I'm going to save logarithmic equations for a later day. Probably going to work on that Monday, which will be our last day of instruction, because I think y'all's exam is on Thursday, so we need at least one day of review. That'll be Wednesday, so we're testing on Tuesday. And so the last day of instruction will be on Monday, where we do logarithmic equations and exponential equations. That will be on the test. It will not be very heavy on the test since we haven't done much with it. Hopefully we'll get some of it tomorrow. Right now, let's move here to activity 1.2. All right. So label each number line using logarithmic expressions with the indicated base. So notice log base 2 of 1/2 is -1. So log base 2 of what would be 0? Anybody want to push back on that, or do we all agree? Why is that wrong? 0 would be the answer. Remember, when you say 0 would be the answer, 0 is the what? Exponent. It'd be what?
Yeah, 1 sounds right.
Because remember, what is the base of my power? The base would be 2, what would the exponent be? 0. And what's 2 raised to the 0? 1.
Yeah.
Don't be down on yourself.
I was thinking of that.
Okay, I got you. This negative 2 here, log base 2 of what would have an exponent of negative 2? 1/4? Remember, a negative exponent tells me to repeatedly divide, and so 1 divided by 2 2's, okay, that's 1/4. So then log base 2 of what would give me 1?
0.
Y'all agree? You think it'd be 2? And keep on that line of thinking, Cameron. What are you gonna say? 2 to the?
Yeah, I'm just trying to do that in my head, cause I don't.
No, but like keep thinking that out. Talk it out. 2 to what? You're using a base 2. What's your exponent? 1. Remember, what the logarithm is equal to is your exponent. What is 2 to the first? 2. Okay, Jay, I know you know how to do this. You got to slow down though. You wanted to jump straight to an answer. You don't have to jump straight to an answer. You got to think. All right. So log base 2 of
6.
I'm hearing 6 and I'm hearing 8. Which one is it? Go back to what a logarithm is. It is an exponent.
It's 8. Yeah, it's gonna be 8.
What?
Cause 2 and 3 is.
Yeah, because if you do 2 times 2, that's 4, and then the other 2 is 6, and then you still got the other ones, 8. I did it in my head. I don't
Wait,
know.
why did you do 2 times 2, but then you added 2?
No, I didn't add 2. 4.
That's how you got to 6.
It's not gonna be 6 or 8, I don't think,
No, it's
It is
then. Is it? I don't know.
It's just 2
We're on
to
third.
the third is 8.
Remember, it's base what?
Oh.
2. What's the exponent?
8.
Exponent 3. So the argument is 8. Does that make sense, Grayson? Huh? Remember, what is a logarithm? It is an exponent. What is the base of the power? 2. What's the exponent? What is 2 to the third? So what's my argument? 8. When I look at log base 2 of 8, what I'm asking is, what exponent goes on 2 to give me 8? The exponent is 3, which is what we have up here. I want an exponent of 3. So then the last one would be log base 2 of 16. Okay? This is going to help us build our comfort and familiarity with these different logarithms. So I want you to fill out the next 3 number lines with your small group. We'll come back together in just a little bit.
So we always go start with this.
On this number line. Can you go beyond that though? Yeah, you could have -3. Could you go past the 4 to 5, 6, 7, 8? Technically, could you even get stuff in between?
Like,
Mm-hmm.
I was good.
Think about our bell ringer. Did we get a decimal for the exponent? Yeah, so we can get decimal exponents.
I think it'd be one.
So we don't.
You're just gonna head put in the log base 3.
Yeah.
Then fill in the argument.
So
And then this would be log
we gotta equal out.
base.
Is there a reason you skipped log base 3?
We gotta equal. Okay, so let's do it. X one.
Oh, so you're just square.
So.
Is this like?
So I gotta find. Yeah.
What does a negative exponent tell you to do? Repeatedly. So you're gonna divide by 3 how many times?
Yeah, I think it's
So what is 1 divided by 3 times 3. 1 divided by.
Seven hours.
Uh-huh. Oh,
Back up at six.
reword that 1
Decent, that's average.
divided by 9.
Wait, which one are you on?
Do you play games?
Okay, so
At night?
base 4. Yeah.
It's just. Haiku. It's the volleyball.
It's like a poem.
Haiku is it's like something Japanese.
Like a haiku where they do
I've been.
Why are y'all talking about haikus in my math class?
Because I'm like.
I see a lot of people that are done, like, or finishing up the
I'm still
log
saying
base 4. Wait.
Oh, like I said 1 over
Oh, wait.
8,
You go to fire.
and then 1 over 4, and then 1 over 2.
I just thought you were talking about 2.
Okay.
3 is log 4, 64.
Yeah.
Log base 3 of what, right? Well, what is my exponent? Okay, so what is 3 to the negative
4.
Stop. Think for a second. What is a negative exponent tell me to do? Divide, so 1 divided by how many 3's? 1 divided by,
Yeah, 1 over 20.
okay,
Oh.
there you go. You're making it too difficult. If you remember that a logarithm is an exponent, super straightforward. Yes, sir.
Which one equals negative 1?
I like this.
Well, what they're wanting is a log base b of, no, they want a logarithm?
You said 1 over 2.
Right.
We don't have a calculator.
So log base b of what is equal to 0?
I don't think I can figure
That, they
it out.
want is a logarithm.
It'd take me 10
What we're
years,
seeing
but-
is log any base
I
of
won't
1
get
is
done at
equal to 0.
9:30.
Absolutely.
So do the same thing for each.
So that have to go with the
5 times 5.
times 5. 20 times 5. I have to go like this. Is that camera still staring?
Yeah, it is.
It's been a while.
I'll move it.
We need this on the test, I like this.
But can you always make your own number line?
If I had to.
If I had to.
If you could just like print out the number line, and then I could just write under it.
Okay, so DJ actually asked a good question or made a good comment. He was like, I need this on the number line, or I need this number line on the test. Hey, what can you do to help you with these things, to help justify your answers?
Great.
Create a number line, right? So, let's look here. Log base 3 of 1/9, log base 3 of 1/3.
So I just covered it with wrapping.
Does anybody have any questions about these logarithms? Maybe they did not get those. We all good? Mm-hmm. No questions? I thought that I saw, the reason why I'm moving through this quickly is because it seems like all of us were getting there. And obviously we have more stuff to learn. If I miswrite any of those, let me know. Any questions there? What is the most fundamental thing you need to remember about logarithms to make sense out of them? It is an exponent. A logarithm, when you evaluate it, gives you an exponent. Any of these logarithms that we have questions about? Does this sound pretty comfortable so far? Alright, let's look at the part A here. Analyze all the logarithms that are equivalent to 0. So referring to all of these. What is a general rule that we could write with using base b? They always equal 1? Okay, so the argument is always 1. So log base what of 1 equals what?
Can you put X
X here or here?
in the base?
In the base? Well, I mean, look at the directions.
This was put B.
Log base b?
Yeah.
Why are we putting a b there?
Base.
Stands for base, meaning that that base could be anything. Kind of. Does anyone know why I say kind of?
Negative.
Ah, b cannot be negative, so it cannot be less than what? Less than 0. Can it equal 0?
No.
Yes, the 0 is gonna be a half of 1. Not gonna be
So remember, if I do 0 to the third, what is that always going to equal? 0. What's 0 to the fourth going to equal? So do we ever want the base to be 0? Not really. So less than or equal to 0. Does anyone know how what I would do to this inequality to say it cannot be less than or equal to 0?
They would have
Oh,
No, it cannot be less than and it cannot equal.
Greater than towards the B, no equal sign. Or no.
Have y'all ever seen that before?
No.
No? If I were to tell you this, what do you think that would mean? X cannot equal 4, right? So if you put a slash through the statement, it's saying the opposite, it cannot, right? B cannot be less than or equal to 0. Does that make sense? Okay. There's one other value that B cannot equal. Anybody remember what it cannot, there's one other number it cannot equal.
Negatives?
Already got the negatives here.
Is it 1?
There we go. B cannot equal 1. Do not forget that. Alright, so analyze all the logarithms that are equivalent to 1. Evaluate all the logarithms that are equal to 1. Log base.
Is equal to whatever.
Wait, what base? Base B. Remember, they already told us base B. Base B of? Remember, what's what we want what's equal to 1. We already did the argument of 1. What did you say, DJ? Log base B of B is equal to 1. Same restrictions, though. Say again, LeJan.
I put B of X instead of B of B.
Well, but you actually can't say B of X.
Why?
Because X does not necessarily have to be the same as the base, right? But look at here, to get a 1, the bases and the argument have to be what? The same. That's why we're going to say log base B of B, to show that the argument and the base are the same. Does that make sense? So yeah, that's something to be aware of. And then part C we're going to move through very quickly. It's just saying rewrite the general statements from parts A and B in exponential form. Well, how would we rewrite this in exponential form? So log base B of 1 equaling 0, that's the same as what?
B raised to 0 equals 1.
Remember, the whole thing about a logarithm is the fact that it's an exponent. It is an exponent. So how would I rewrite the other one?
B raised to 1 equals B.
If you start thinking about these as exponents, this makes your life much easier. I don't care about a Zoom update, I gotta teach. I used to use it very heavily for tutoring when COVID was really prominent. I need to stop paying for it, to be real. Alright. So notice, and we're not going to spend a long time here because we need to move to the next lesson, but what we're doing is we're estimating with logarithms. What we just did is we used a number line to get the integer values. Well, what if the exponent's a decimal? Notice Sutton here says log base 4 of 16 is less than log base 4 of 28, which is less than log base 4 of 64. Well, since 28 is between 16 and 64, that logarithm has to be between 2 and 3, according to Sutton. Silas said that he estimated the log base 4 of 28 by converting it into an exponent, and knowing that 4 squared is 16 and 4 cubed is 64, log base 4 of 28 must be between 2 and 3, and so he got what, 2.4?
I can never get 1.4
I believe it has squiggly marks, doesn't it, instead of an equal sign? So he is saying it is approximately equal to. Why do you think they went with 2.3 and 2.4 instead of, say, 2.5 or 2.7 on the estimating side? Why did you think 2.3 and 2.4 are closer? What do you mean by that? Yeah, but like, why did they choose to say why would Sutton say 2.3? Why wouldn't he have said 2.8?
Oh, because you're just saying it's between 2 and 3.
Uh-huh. It could be, so why did he choose 2.3 instead of 2.8?
It's closer to 2 than it is 3.
What is closer to, like, how does he know? Y'all are skipping an important detail here. We're looking for a what? An exponent that goes on the base to get the argument. Look at the arguments. Why would you go with 2.3 as the exponent instead of a 2.8 as the exponent? How though? That's what I'm asking. You're forgetting that the exponent is supposed to get us to the argument. What is 28 closer to? Oh, 28 is closer to 16 than what? 64. So the exponent needs to be closer to the 2 or to the 3? Closer to the 2, right? I would probably guess 2.2, honestly, because I feel like 28 is pretty darn close to 16. I'm estimating, I don't know for sure. Pick up a calculator. What is log base 4 of 28? $2.4, so I was off. Okay, that's fine. I would have guessed 2.2 though. You know what I wouldn't have guessed? 2.8. Right? Because 2.8 is so much closer to 3 that the argument should be closer to 64. That's what I want us to recognize here with this whole estimating process. And so go back to what we just worked on, those number lines. If I'm looking at log base 2 of 10, what could it be between? Look at the number lines we just developed. What could log base 2 of 10 be in between?
8 and 16.
So log base 2 of 8 would be less than log base 2 of 10 would be less than log base 2 of 16. So what could we estimate this to be in between? What two numbers for the exponent?
16.
Nope, I'm thinking about the exponent now. What is this exponent? 3, and this is? So the exponent needs to be about what? 3.5? I would have said 3.3. Why are you going less than 3.5?
It's closer to 8.
That 10 is closer to 8, isn't it? That's what we want to notice. That's the reasoning I would need to see from you on an understanding check with these kind of things. Okay? So I might have you fill out a number line and then use that number line to approximate some of these values on an understanding check. Pick up a calculator. What is log base 2 of 10? Oh, I had no clue. I just guessed that. I think that's what you said, wasn't it, DJ? So DJ just guessed that, and notice, but that's close, right? It's closer to 8, so it's gotta be closer to that